Hello everyone, you're welcome to Wise Man's Online Mathematics. The topic on the board is binomial theorem. Now, binomial theorem is a method used in expanding powers. Like if you have, let's say x plus y raised to power maybe b. So we are to expand this bracket in this number of power here in b power. So we are going to be using binomial theorem to expand different kind of brackets. Now, in binomial theorem, you need to use what we call the binomial coefficients. Binomial coefficients can be gotten in two ways. There is the longer method and there is the shorter one. Now, let's talk about the Pascal triangle. From the Pascal triangle, you can get your binomial coefficients in this way. Now, let's consider it like this. Let's talk about the power. We'll talk about the power. Now, then we'll now form the triangle from here. The Pascal, that is the coefficients. Let me call it the coefficients. The binomial coefficients. Now, binomial coefficient from Pascal triangle is from the Pascal triangle. And then we can also get it from the combination. If you don't use the Pascal triangle, if you can use a combination, you see it in your calculator in this form. So NC, you see C. Most calculator carries C, while some carries N with what? C. Now, whenever we have power 0, whenever this B is power 0, the coefficient is what? 1. Now, I'll talk about that later. Now, let's go again. If you have your power to be what? 1. If your power is 1, how do you form this triangle? Is, as the word implies, a triangle. It's an array of numbers in triangular form. So we're going to be starting with 1 and it must also end with 1. It starts with 1 and ends with 1. And you add in between the digits. Like this. For power 1, it will be 1. For power 1, it will be 1, 1. Now for power 2, you go like this. You start with 1. You add in between 2 and end with 1. For power 3, you start with 1. You add in between 3. You add in between 3, end with 1. For power 4, you start with 1. You add in between 4. Add in between 6. Add in between 4. And then end with 1. For power 5, you have 1. Add in between 5, add in between 10, add in between 10, add in between 5, and then end with 1. For power 6, you have 1, you start with 1, and then add in between 6, add in between 15, add in between 20, add in between 15, add in between 6, and then 1. So this is how you form the triangle. So you observe that it's actually forming a shape, which is a what? Triangle. So this is how you get the coefficient from your Pascal triangle. So what about if we are talking about a larger power, like let's say 100? So will you be forming this? So there's a shorter way. We'll be using our combination to get that. So for this, for anything raised to power 0, we already know is 1. Anything raised to power 0 is what? 1. Provided that the base is not 0. So anything raised to power 0 is 1, provided it is not 0 raised to power 0, because it is undefined. 0 raised to power 0 is what? Undefined. So 0, this is x plus y raised to power 0. It must give you what? 1. Now, what about for 1, 1? How do you form this? You have your n. Definitely your n is this power. So we are going to be starting with 1 combination 0 and 1 combination 1. So when you get 1 combination 0, you get your 1. 1 combination 1, you get your 1 with your calculator. Now what about if the power here is 2 and you don't have the time to form this Pascal triangle and you need a coefficient? Because when we be expanding this, you need a coefficient to expand. So if we're talking about this, if you want to get this first coefficient here, which is 1, all you just need to do is to carry this. This is your n. That is your n. Your 2 is your n. So you start like this. So for this is for this. So let's go for this now. So you have power 2, 2 combination 0, 2 combination 1, 2 combination 2. So when you get 2 combination 0, you get 1, 2 combination 1, you get 2, and then 2 combination 2, you get 1. What about for power 3? For power 3, how do you get it? Your n is also 3, 3 combination 0, 3 combination 1, 3 combination 2, 3 combination 3. So when you get that with your calculator, there's a part in your calculator that has this combination, and there's a part also have p, that is your permutation. So we are using the combination. So what about this? How do you get the coefficient if you don't have the time to form this triangle? You have the power there is what? 4. So you have 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, 4 combination 4. So when you get this with your calculator, 4 combination 0, you get 1, 4 combination 1, you get 4, 4 combination 2, you get 6, 4 combination 3, you get 4, and 4 combination 4, you get 1. So even if you are giving, let's say to the power 0, to the power 100, let's say we are expanding this bracket to power what? 100. So how do you write it? You start 100 combination 0, 100 combination 1, 100 combination, 100 combination 2, 100 combination 3, that until you get to 100 combination 100. So when you press this with your calculator, it's much easier. You just press 100 combination 0, you get the coefficient, 100 combination 1, you get a coefficient, and in that manner you get it up to the last 100 combination 100. So in my next video, I'll be using this particular coefficients to expand brackets. So irrespective of whatever power you have here, you can use your binomial theorem to expand. Thanks for watching. Bye bye.